everyone, Graham here. Wanted to give you a brief overview of the Christmas light tunnel that I built. This tunnel is 20 feet long, 10 feet wide, and about 9 feet tall. It has about 28 strands of WS2812 lights on it for a total of about 3,500 lights across the entire tunnel. The tunnel was built using 1/2-inch Schedule 40 pipe cut in 5-foot sections, and those pipes are anchored to the ground using fiberglass rods, just like you see here. That allows for it to stay in place for the couple weeks I have it up, but allows for easy disassembly once Christmas is over. There's also a rope that goes through every horizontal and vertical piece and is clamped on each side, and that's what just kind of gives the tunnel a little bit of rigidity when it is windy out. This tunnel was built in 4 sections, and each section is 5 feet long. Each section also has 7 strands of lights, and over here on the left side is where you can see we do the power injection and data splicing for each section. So the way this works is the lights start on the left, are draped over to the right, they're clamped, and then there's 4 null pixels, and then they are brought back over to the left where they are spliced into the next strand and also power injected. This allows for power injection of once every 256 LEDs and allows for continuous data stream from the start to the end. Each section has 2 channels, so the first 4 strands of lights are on channel 1, and then the last 3 strands of lights are on channel 2. So each section has its own power and data lines, and those lines run up to this controller box that you see over here. So this is the controller box that is used to run the light tunnel. The controller box was divided into 2 halves. The bottom half controls sections 1 and 2 of the tunnel, and the top half controls sections 3 and 4 of the tunnel. In the middle you can see the power supplies. These are 5-volt 20 amp power supplies, and they deliver power to both the LEDs and the microcontrollers. On the right hand side you can see the microcontrollers, and I have 1 microcontroller per section. These are the WT32ETH01s, and they've been flashed with WLED. I am a huge fan of these controllers because they have an Ethernet port, and with me being a network guy, if I can hardwire something over wireless, I will do it any day. So as you can see, off each controller there's an Ethernet cable that runs to a switch, and then that switch has a network cable that runs out of the box and up to the house, and in the house I have a small computer that runs the visuals using Falcon Player. Off of each controller you can see there are the 2 channels for each section. A couple other things to note in this box. At the top and the bottom here there is an NE555 timer, and what this does is this allows me to give a little bit of a delay in delivering the power to the microcontrollers when the box turns on. One of the big problems with these power supplies is that they do not immediately give 5 volts when they are powered on. They ramp up, and that causes an issue with the microcontrollers because they expect 5 volts and that glitches. So what this does is this gives a brief 5-second delay before it delivers power, so that they can get a clean 5 volts. And I will actually show a little screenshot here if you're looking at using these controllers, how they're wired up. A couple other things to note. Up here, down here, and up here, this is a block of null pixels. So the lights run at 5 volts, the microcontrollers run at 3.3 volts. So what this does is this takes the light signal from the controller and allows it to be regenerated for 5 volts when it gets sent out to the tunnel. Without this, the signal from these microcontrollers is not strong enough to reach the tunnel, and you'll get glitching. And the final thing to show you is underneath each one of these heat shrinks is a 200 ohm resistor. So after I built this, one of the big problems I had was I was getting this erratic flickering when I was getting a lot of data light change or light changes on the tunnel, and it was because there was a reflection on the data signal that was being sent back to the microcontroller and causing a collision. So what this resistor does is it absorbs that reflection and gives a good clean signal to the tunnel. So thanks for watching this build overview. If you have any questions, feel free to leave a comment below.